Hello and welcome to another part of the random problem challenge. Today we're going to pick another medium problem and see if we haven't done it. Okay, let's take a look. Okay, we haven't done it. Add two numbers. You're given non-empty or linked list given two non-negative numbers. Okay, the most significant digit comes first. Okay, and each of their nodes contain a single digit. Add the two numbers, return the sum. Okay, this is pretty straightforward. I don't think I have to write down any notes. This is just linked list operations here. So the only question is, so this most significant digit comes first, which means if we have like numbers like 7, 2, 4, 3, well, let's just take these smaller numbers, right? So 2, 4, 3, then we have 5, 6, 4. How did they want us to add? Okay, so it's 807. Okay, so what we're gonna want to do, I think, is probably reverse them because that doesn't cost us anything, and then it'll be a lot easier to work with. Yeah, yeah, because we're gonna need to add from the right, not the left. Yeah, yeah, definitely. Okay, so so our plan is reverse the two lists, and then um, and then do the addition. So we can make a little helper function, I think, called reverse, and it's just gonna reverse the list and then return the new head. Yeah, sure. So def reverse. It's gonna take a head, and we are going to return the new head. Yeah. Okay. So how long do these speed? Do they have to be one node? Okay, so there has to be so it's never going to be non-empty. Okay. So we need previous equals none, and we're just gonna do a simple reverse. So while head, I think. Yeah. So current is going to be the head. Sure. Or we can just make a cur, so it's fine too. So cur equals head, while cur, and then we're just gonna do the standard reverse. So temp equals cur dot next. Previous dot next equals cur. Okay, yep. Cur dot next equals previous. Actually, no, I don't think we want this previous dot next to be cur. Yeah, we definitely don't. Okay, so we need temp equals cur dot next. Yeah, because like if we want to reverse this list, the 7 would have to point to nothing. Yeah, okay. So cur.next equals previous, then we can just do previous equals cur equals temp, and then we return temp here. Okay, so that should do the reverse of a list. Pretty sure. Yeah, I could do an example real quick here. If we do like 5, 6, 4. So our head will be 5. So we'll just say that, yeah, 5 will point to nothing, and then we'll be at 6. 6 will point to 5. Yeah, okay. Yeah, and then we actually want to return. No, we don't want to return temp. We want to return previous. Yeah. Okay, so that'll do that. So let's just get these lists reversed. Yeah. So we're just gonna say head 1, head 2 equals reverse L1 reverse L2. So now we get the two heads. So now our nodes are going to be in the order of like this: 3, 4, 2, 7, and then this is just a basic like addition. So yeah, so I think we want to probably make a dummy node. Yeah, let's do that. So dummy, as usual for all these linked lists, it's good to have a dummy node. So list node. We'll have it be equal to nothing, and then cur equals dummy here. Now we're going to go through these two lists. So while head 1 and head 2, if head 1 dot val. Oh, actually, no, we don't need to do the if. We're not checking for the smaller thing. We also do need a carry in, right? So like when we add these numbers, we might have some kind of carry out and carry in, so we need to do that. So we'll just call that cn equals 0. There we go. Perfect. So while there is one or the other, what we need to do is we need to add them. So it's going to be res equals head1.val plus head2.val plus cn. And then we are going to, yeah. So that's going to be the res. Now what we do need is we need to actually have the C like the carry out again. So that's going to be equals res divided by 10. Yeah. So like if our result here, like if we add these two nodes and we have like a 4 and a 7 and we get 11, we want our carry out to be the 1. And so that's going to do that right here. Okay, now we need to do dummy.next equals, we need to actually create a node, so list node of res, and the value here needs to be actually res modded by 10. So like if we do a 4 plus 7, we actually want to keep, or sorry, not a 4 plus 7, let's do a 4 plus 8, it's going to be 12, and then 1 is going to be the carry out, and then 2 is going to be the number that we actually want to store here. Yeah. Okay, so that's going to be that. Yeah, this is not dummy, this is cur. Okay. So we have the carry out, we made our new node, so now we just move our stuff. So cur equals cur.next, head1, head2 equals head1.next, head2.next. Okay, so now we might have run out of one list, and so we need to check for that. So while head1, so if there's a head1, we ran out of head2. So if we have some long number here, right, like this, and we added all our digits already, we added all this stuff. So now we're at this point. So now what we need to do is we need to just keep going through this until we used up all the values. Yeah. Okay, so that's going to be, yeah, so res equals head1.val plus cin. Cin equals res 10. That's all the same. I mean, let's just copy some of this code. So cur.next. That's fine. Cur, and then this is just head1.next. Okay, so now we went through head1. Now we need to go through head2 because head2 might be longer. So it's literally the same code. We definitely can like make this cleaner by not reusing the same code, which, you know, if you want to refactor a little bit, I would encourage that, but time and space and whatever, it's not going to matter. So head2.val, and then head2. Okay, so now there is one other case, and that's if we have some numbers like, we have some equal numbers, let's say, right, like 9999 plus 9999. We will go through them, but we could still have like a carry out. So we do have to see if there's a carry out left over. So if cin, then we have to make one more node. So cur.next equals list node 1. And then that's it. Now we just return dummy.next. Okay, let's just go through. Oh, no, one more thing. So one more thing. So we actually do need to reverse the list here. Yeah. So we need to return the list. And so our list is going to actually right now go the other way. Yeah. But it's going to start at the dummy. So like if this was 70, so this would be like dummy points to 7 points to 0 points to 8 points to 7. And what we need is we need to reverse the list starting from here. So we actually need to get rid of the dummy now, and then yeah. Okay, so what we need to do is we need to say head equals dummy.next, then dummy.next equals none. We don't want that anymore, and now we just return reverse head, and I think that should do it. Let's just go through this code again. So here we have a reverse. We can definitely, it's going to be like, I think in a realistic interview, as long as like your logic is right and stuff, it's going to be very easy to make a syntax error. It's almost impossible not to, but let's go through it. So we have a reverse, which I think is correct. Now we reverse list 1 and we reverse list 2. Makes sense. We make a dummy. We make the cur equal to dummy. We make a cin. So res equals head1.val plus head2.val.cin. Yep. Cin equals res mod 10. Yeah, that's our, or sorry, divided by 10. That's our carry out. So if we had like 11, we'd carry out a 1 here. Cur.next, we have the mod, which makes sense as well. This has to be a 1-digit number. Craig will score that next. We update these. Yeah, I think looks good. Yeah, let's try it. Okay. All right. Osse's had 2 and 1. Oh, did we? That would be shocking. No mistakes. Wow, crazy. Okay. So definitely can refactor this code if you wanted to, and the way you would do this is you can just have if checks. Like you can have while head 1 or head 2, and then you could just say like if one of them it doesn't exist, then just use the other one. So that would be one thing you could do. But I think time and space complexity wise, let's think about it. So time. So reverse is going to be big O of like, let's just say L1 is length M, and then L2 is length N, let's call it. Reverse doesn't actually cost us anything because we're going to have to go through, like, it's going to be like this. And so if we reverse one of these lists, that'll just be something like 2M plus N or something, which doesn't matter. So we reverse them both. And then so that's, like I said, that's just going to be, doesn't really matter because we still have to traverse the entire thing. So we have to traverse the first and the second list. And so if they're length M and N, that means that they would be, yeah, if they're length M and N, that means this would be the time complexity. So we would have to traverse both of them. Okay, and then yeah, we do have to reverse the output, but that also doesn't matter. So if it's like 3M plus 3N, that just gets canceled out. Okay, space. So if you do count our result, then it's going to be M plus N space because we did make a new list with all of these nodes. If you don't count the result, it's going to be big O of 1. So whatever. You know, I think sometimes you do count results, sometimes you don't. So you can just talk about that, and I think it's fine. So the result is this, and then the actual anything else we made would be big O of 1. Okay, so that's all for this problem. Hopefully you liked it, and if you did, please like and subscribe, and I'll see you in the next one. Thanks for watching.